Okay, today we're talking about multiplying a multi-digit number by a one-digit number. Your objective, your I can statement is I can use place value to multiply a multi-digit number by a one-digit number. Now that's the same objective we had yesterday, except for today we're adding one new word. I can use place value and partial products. Now you're probably saying, what is a partial product? We've done problems like 3 times 27, where we've used our distributed property to go 3 times 20 plus 3 times 7. The answers we get from 3 times 20 and 3 times 7, these are our partial products. They're partial because here's the whole number completed, but this 20 is only part of the 27. The 7 is only part of the 27. That's why we call them partial products. I'm going to show you 2 ways to solve a multiplication problem. I'm going to take the problem 137 times 2. First thing I want to do is I want to estimate my answer. I want to make sure my answer is somewhere around the right thing. So when I look at 137 times 2, this rounds off to 100. So I really have 100 times 2, so my estimate is 200 for this problem. Now, we've talked about drawing the box already. You know that the 2 goes on one side, and then you use your expanded notation to break up the 137 to be 100 plus 30 plus 7. Wherever you put the plus signs, you draw your little lines. Okay. Now, when we do it as an algorithm, this is what your problem looks like. 137 times 2. All right. Now let's go ahead and do the multiplication steps on both of these, but I'm going to do the corresponding steps on both sides. For example, first thing we do here is we multiply the hundreds. So this is 2 times 100. We know that gives me 2 hundredths. I have to do the same thing over here. Now remember, these numbers are really 100, 30, and that one is 7. So I'm actually going 2 times 100, and it gives me 200. Now we're going to look for the next one. Now we go to the next step, which is to multiply the tens columns. This case, we've got 2 times 30. And I know 2 times 3 is 6. Just drop down the other 0. Now on the algorithm side, I'm going to do the same thing. 2 times 3, I know that is 6, and drop down the 0. The hard part is right here, keeping all your numbers lined up correctly. The last thing we need to do is to multiply the one-digit number by the ones. So this gives us 2 times 7. We know that 2 times 7 is 14. We have the same thing over here. 2 times 7 gives us 14. Notice how I've lined up all my columns. Now, I don't really like to add numbers up when they're as a number sentence. I like to change them into an algorithm. I just find that so much easier. An algorithm is when the numbers are written one on top of the other. So let's do this one. 0, 0, 4. 6 plus 1 is 7. And 2. Our estimate of 200 is kind of reasonable. Now let's check the algorithm side. 0, 0, 4. 6 plus 1 is 7. Bring down that 2 because there's nothing to add to it. So we've got 274 and 200. I'm going to do just one more for you, and then I'm going to give you your assignment for the day. Okay, here's the next one I want to do. I want to do 4 times 471. Okay, the first thing I'm going to do is I'm going to estimate. This E stands for estimate. Now, when I round this off, the 4 has to go up and become 5. I know 5 times 4 is 20, and I got 2 more zeros that I got to add. So I'm looking for an answer that's pretty close to 2,000. Again, I'm going to do the algorithm on, I'm going to do the algorithm on one side, and I'm going to do the boxes, the model, on the other side. I'm going to start with my boxes. All right, I want to take this number into expanded form. And 471 in expanded form is 400 plus 70 plus 1. All right, now to write it as an algorithm, I have to write 471 times 4. Okay, I'm sure there's nothing there that you haven't seen before. Now let's start doing our multiplication part. First thing we have to do on our model side is the hundreds. So this gives me 4 times 400. I know 4 times 4 is 16, and then I got 2 zeros to add. Now on this side, you got to remember, even though this looks like 4, it's really 400. Even though this looks like 7, it's really 70. And our poor little 1 is a poor little 1. So now I have to do the 4 times the 400. 4 times 4 is 16, and I have to add my 2 zeros. Now we're going to move over to the tens column. Now we have to do 4 times 70. All right, I know that 4 times 7 is 28, and I've got 1 zero there. I have to do the same thing over here. 4 times that 7, which is really 70, which again is 280. Then the last thing we have to do is the ones column. The ones column has, oops, I don't want to use that color, I already used it. Let's try orange. Okay, now we're going to go 4 times 1. Okay, 4 times 1, which we know is 4. And we have the same thing on the algorithm side. 4 times 1 is 4. Now we got to add these up, but like I said, I like to line up my numbers. 4, 8, 2 plus 6 is 8, 1. So our estimate of 2,000 is pretty good. Okay, let's look at the algorithm side. 0, 0, 4, 8, 6 plus 2 is 8, and 1. So we came up with the same number both times. Okay, here's what you're going to do today on your own. All right. I want you to solve, but I want you to use the algorithm method. All right, so I'm going to give you Oh, let's do this one. Looks pretty easy. 3 times 190. That's one you have to do. And remember, the algorithm is written like this. So I kind of helped you out there. And then you've got one more problem to do. I'm only giving you 2. And let's see. How about... Ooh, this one looks kind of interesting. I'm going to use a money problem. This is 395. Oops, I don't want to write it that way. I want to write it this way. It's going to be times 6, I think. Yep, 6 times $395. $395. Okay, you should estimate and solve. All right, when you get it done, come show me those 2 problems and I'll give you your next assignment. Okay? Enjoy. Remember, you can always move the video back if you need to get back to the screen with the problems on it. See you at the end.